Thank you for volunteering to be a judge for the Thompson School District Science Fair. An effective judge knows that this is an important experience in the life of every participant. Please make sure all participants remember the science fair is a positive experience in their life. Some notes on being an effective judge. For many students, you may be the first person who has ever interviewed them. They may not know how to start talking to you, so what we would like is for you to approach a student in a friendly and professional manner. Introduce yourself and then ask them to explain their project to you. This gives them an opening to start talking to you. Ask questions, but do not provide answers for the students. Some of the students have a tendency to repeat your suggestions to other judges. Then they skew the results because they might tell a judge something that you said instead of something that they discovered on their own. Make sure you are fair to all the participants. Spend about the same amount of time with each student and project. Carefully listen to the students' explanations of the project and find out how the project was done in an approachable and non-intimidating manner. This is what a 4th through 5th grade scoring sheet looks like. The top part has a place for the student's name, project, and grade. This information should be on your judging sheet when you get them. There are times that you may need to add this information yourself, such as when we have extra kids for you to judge. The top right corner says upper elementary. This lets you know that the scoring sheet is for the upper grades, and for most science fairs, this is going to be 4th and 5th graders. The next section is for comments, and you will write your comments below the comment line, but above the cut here line. This section is really important to fill out. This is how you provide feedback to the students about their project and their presentation. Please keep the comments positive. If there's something they could have done better, feel free to explain what you would have liked to see and why. For every improvement, please also provide something they did well. The sheets will be cut on the cut here line, and the students will only see the part above that line. This is the part where you will score the student projects. This section provides the information that we want the projects to be evaluated on. Please be consistent on your scoring between projects. You will use these scores to rank your placing for the students. After you have finished judging, you will come back with your team and discuss placements based on each judge's ranking. These points are to help you evaluate the projects on the criteria important for the student to become successful scientists. Because each judge will award points differently, it is important that you work as a team to discuss ranking based on each judge's rank, not on raw points. Remember, this part of the score sheet will be thrown away after final ranking, and no student will see these scores. So you can use this piece of paper to write any notes or comments to yourself that you would like to remember. Points are awarded based on how well you feel the student meets the requirements listed on the score sheet. So if there's no evidence of meeting the requirement, you'll give them a 0. If there's some evidence that they meet the requirement, give them a 1. A 2 would be maybe if they met the requirement, but you feel like they could have done a little more. And then 3 would be if the requirement is met and done very well. So like the exceptional student. There are 4 areas of focus for judging an upper elementary project: scientific thought, thoroughness, creative ability, and clarity. Under scientific thought, the first question is whether the problem has been clearly stated. The student should have a question or problem that they are trying to answer. For example, will the color of my eggshell affect the taste of the egg? Procedure was appropriate, easy to understand, and should have yielded consistent results. The student should have created an experiment that will give them an answer to their question. The steps they take in the procedure should be easy for you to understand, both the sequence and why they did the steps they did. Also, the procedure should be done in such a way that the results over multiple trials would be consistent. For example, if they're racing a car down a track and they run the experiment 3 times, should the results be consistent based on their procedure, or are they pushing the car with their own force, thus making their push an extra variable in their experiment, which can make the results inconsistent? The variables, independent, dependent, and controlled, are clearly recognized and defined. There are 3 different types of variables that we want 4th and 5th graders to start recognizing and to understand how they influence the results of their project. The students should list these on the board, but if they don't, it's okay if they're able to tell you what they are. Let's go into these in a little more detail. Okay, An independent variable is the one variable that you want to change. You should only have one changed variable in your experiment. For instance, if you were trying to see how far a toy car can travel after going down a ramp, your one variable that changes could be the angle of the ramp. The angle of the ramp is the independent variable and should be the only thing that changes in the experiment. Of course, you can have multiple angles, but only the angle should change. A dependent variable is the one that responds to the changes that you make to the independent variable. This is the variable that you observe or measure. In the car example, you would measure how far the car travels from the end of the ramp to where it stopped. Control variables are all the variables that could cause your results to change. You want these variables controlled so that they don't affect the results of your experiment. Some variables that should be controlled are the car they used. They should always use the same car. The ramp should be the same ramp, just move to a different angle. For instance, one ramp shouldn't be made out of cardboard and a different ramp made out of a different cardboard or made out of wood. The length of the ramp should be the same in each experiment. Most experiments that the kids will do will have more than one controlled or constant variable. Results are accurate and consistent, and any errors have been adequately explained. If the procedure was done properly, then the results should be accurate and consistent. If they are not, can the student explain why? In science, it's very important that the results are accurate and don't vary wildly. If there are errors, students should understand why they have the errors and what they could have done differently to control those errors. Moving on to the focus of thoroughness. The project was designed to answer the question. Sometimes we see that students create an experiment that doesn't answer the question or the problem that they are trying to solve. By 4th and 5th grade, students should be able to design a project that will give them an answer to their question. The conclusions are based on an adequate number of trials, typically at least 3. Younger kids sometimes don't realize how important it is to run multiple trials to get accurate results. By 4th and 5th grade, students should be running at least 3 trials of their projects so they can see whether their results are consistent with each trial. Research was evident and relevant to the project. The students should have done some research on their project. It could be as simple as looking up the meaning of words relevant to the project. Ideally, we want to see them research whether the project has been done before and be able to explain what they're doing different or why they're repeating an experiment where they've already seen the answer. Creative ability. The project is creative and original, which means unique and attempted at an appropriate grade level. Many times elementary students find their projects online or in a book, and that's a great way for them to start learning how to do science, but we really want them to start thinking about questions that they have and how they can answer them. We want the students to have a genuine interest in the project they choose. We also want the project to be at a grade level that they can understand. You will have to judge for yourselves if you think the student is capable of the project they are doing. At this age, some of the kids are really smart and really creative, so your judgment will partially have to be based on their understanding of their project. Also, we want this to be the student's project, not the parent's project. It's okay for parents to help, especially if there's something dangerous involved. We actually want parents' help then, but otherwise the students should be doing the project by themselves. Also, if there's something a student could have bought but instead made, even with extensive help of the parents, this should reflect positively on the student since they learn more from the project by making the solution than from buying it. An example is one time we had a student who was doing a cheese experiment. And for the experiment, they needed a cheese block to shape the cheese. Instead of buying the cheese block, the student's parent helped the student make the block. The student learned more from the making of the block than they would have learned from just buying the block, so they should actually be rewarded for that. Even though their parent helped, they should be rewarded and not penalized. Rate the display's visual appeal and organization. We want to see the kids' work, not their parents, and we want to see how well the kid can organize their board and make it look good. The display should be grade appropriate while also displaying the elements of their project. Okay, clarity. How clearly does the finalist discuss their project and explain the purpose, procedure, and conclusions? The student should be able to tell you what they did, why they did it, and what the outcome was. How well does the project display explain the project from start to finish? The display board should explain the major elements of the project. If the student isn't there, a spectator should be able to figure out what the experiment is about and what conclusions were reached. In the upper elementary grade level, the student should be organizing their board in an orderly fashion. So typically it should read like a book with the project being explained in the order it happened and starting from the left top and kind of ending at the right bottom. Does the student speak clearly, make eye contact, and show enthusiasm for the project? This one's kind of self-explanatory. Okay, so some important things for you to remember as you're judging. The questions address elements that are important for a successful science project, and these are the elements we want you to focus on when you're judging the student. Please use the questions and your scores to help you rank the students for second, third for awards as an individual. And then when you go back with the members of your judging team, you will discuss your rankings with them to come to an agreement on the overall ranking for the group of kids that you are giving placements to. Make sure you fill out the comments section on the top of the page so students can receive feedback on their project. Thank you so much for offering your time to judge these kids. You really are making a difference in their life, even though you may not see it. I've been doing science fair for, oh gosh, like 10 years now. We've been doing this, and the kids, it's really amazing to see the kids grow and come out of their shell and become many little scientists. They really, really start thinking about how to think like a scientist, and you are a very important part of that. So thank you very much.